Diabetes mellitus comprises a group of chronic metabolic disorders where insulin secretion or action is impaired or absent, leading to hyperglycemia. Type 1 diabetes is characterized by a complete lack of insulin production. To compensate this defect and to achieve adequate glycemic control, the affected persons have to inject insulin in ways best imitating normal physiology. One important element of standard of care is carbohydrate monitoring. Studies have shown that patients estimate the carbohydrate content of the meals inaccurately with an error of the order of 20%. The aim of the GoCARB project is to simplify this task using computer vision.
An individual with type 1 diabetes will need a smartphone, a credit card-sized object for reference, a dish which they want to estimate the nutritional content of, and a blood glucose meter. The first step is to measure the blood glucose level. These values will now be transmitted to the smartphone via wireless interface while we go through the application. For this, we take 1 and 2 photographs of the dish from different angles for the CHO estimation procedure. This procedure is made in 5 distinct steps. The first, segmentation, separates the different food items so that they may be processed individually. The second, recognition, uses artificial intelligence to understand what these items are. The third, stereo vision, constructs a 3D model of the food to scale using the 2 images and the reference object. After which, 3D model and segmentation are merged to determine the volumes of individual food objects. Finally, food types and volumes are combined with a nutritional database to build the profile of the meal. Now, since the results are available, we'll go through them together. Visible here is the recognition map, where each color represents one type of food, namely yellow for pasta, orange for breaded food, and green for vegetables. The application also displays the volume of each food item, the corresponding carbohydrate content, and the total grams of carbohydrate. At this point, the user is prompted to accept this estimate or enter their own. Then, an automatic bolus advisor uses the nutritional profile, the blood glucose measurement, and rules defined by diabetes specialists to suggest an insulin bolus, which may also be overridden by the user. At the end, the meal intake and insulin bolus are saved into the app history to serve as future reference for patients or physicians.
In closing, this novel application provides unique information on carbohydrate content of meals. This should allow persons with diabetes to optimally define a necessary meal bolus of insulin and can be truly useful in unfamiliar settings such as restaurants. Our technology strives to promote self-confidence, self-reliance and a better glycemic control in persons with type 1 diabetes.